Calculus Camp. This is Dr. Callahan with week 17 Monday. How are you guys doing? I hope you had a wonderful weekend. Go ahead and pause the video and answer the following 3 questions. All right, you guys. So this week is week 17, and your focus this week is going to be on Unit 7 on your Albert IO. So you need to go ahead and pick, and there are 100 questions. You could pick any 30 out of the 100. You need to focus on Unit 7, which is on differential equations and slope fields for semester 2 for this Monday, Tuesday, and Wednesday. And then we're going to move on to the last unit, which is application of integrals, area under the curve, volume, velocity, and acceleration for week 17, Thursday, and Friday. And for this one, you can go ahead and pick any 20 out of the 107. So 50 questions altogether. Now, if you need some assistance with some of the questions there, the principal review on page 357 and also 317 offers you the examples and then also the notes on kind of like a note summary on these 2 topics. So keep that in mind. And then after this week is the last week before your actual AP exam, and that's going to be on week 18. Monday through Friday, you will take your second projects exam, and then week 19, Monday, which is going to be the 24th of May at 8 a.m. in the Career Center, you guys will be taking your AP exam. So just keep that in mind. So this week we are in May 10th, which is going to be week 17. Next week is week 18, and then week 19, Monday, 8 a.m. Career Center is where you'll have your AP exam. The breakdown of your AP exam is as follows. It's going to be 4 different sections. As you guys are probably aware, multiple choice with calculator, no calculator, then free response with calculator, no calculator. Now the time frame is a little bit different, so you get a little bit more time with a calculator for the multiple choice, but you get the same amount of time, 15 minutes a question with the free response, with or without a calculator. And just keep in mind with the no calculator, there are 4 free response questions. So just make sure you plan accordingly. Make sure you have enough energy after, 2.5 hours that you still have another 60 minutes to go with the free response questions. All right, so I'm not sure if you guys were aware, but I did post this on MS Team. AP College Board actually released the actual questions for free response that appeared on the 2021 test. And initially when I saw it, I was like, that's interesting because you guys haven't taken the test yet. But then it came to my attention that you guys are probably going to be given Form B of the free response question for 2021. But for the 2021 regular free response question, these were the questions that were the actual questions on the task. So I wanted to make sure that, if we actually go over this, this might be a good indicator to see what's actually on the test and what's not on the test. So here's question 1, question 2. And there are 6 questions, obviously, 2 without a calculators, 4 with the calculators. And if you need the videos for these 6 questions, I do have it right here for you guys with this QR code. Questions 3, questions 4, questions 5, questions 6. And what I would like you guys to do is, I'm curious as to if there are any similarities between Form A and Form B of the free response questions. I think that's kind of important to know, so that way you can actually see if there's a linkage between the 2. For example, if they already asked you a question on differential equations in Form A, then is there a likelihood that they will ask you a similar question on differential equation for Form B? Because if they're not going to do that, then you really can take that to eliminate, the chances of that being on the test. So then you can go ahead and study a little bit differently in that aspect. So for week 17 Monday, I want you guys to go to this link right here, and you can use the 2 QR codes and review the type of questions from free response question A, which are the 6 questions I've already shown you guys for 2021, and free response B from each year leading up to 2018. Now, of course, they haven't shown you guys free response form B for this year because chances are they're going to give that to you. But I would like you guys to take a look to see if there's any similarities or differences from the year starting in 2018 and then the previous years before that. So to ask you what type of questions are asked for free response question A versus free response question B. Are the questions similar in the two or are they different? And then after reviewing this info, how can you apply this new knowledge in studying for the AP exam? So with that said, I'm going to show you guys what I'm talking about when you guys actually get to that point. Okay, so let's go ahead and take a look. Once you type that in or you use a QR code, you will get to this point right here. And as you can see, here is free response starting in 2018. They don't give you anything before or after that, like 2019, 2020, 2021. But if you take a look at the free response in 2018, here is 2017, 2016, and there's actually no Form B. But there is a Form B once you get into 2014. There we go, starting in 2011. Okay, so as you can see in 2011, you do have Form B right here. So my question to you guys is, as you're looking at the questions from 2011 Form A, are there any differences in Form A and Form B? So if I click on this link right here, you'll be able to see the questions that were asked in 2011. And so I see a question on velocity, a question with a charge, a question with that looks like area, maybe volume, and a question that is going to be on average rate of change. So those are the questions that was asked on Form A. So then I can have you guys click on Form B and take a look to see the questions if they're similar. Okay, so they're somewhat similar. I mean, like there's a chart question there. Let's see if there's an area question. And there is an area question, obviously. So somewhat similar to it, but not 100% similar to that. So then starting in 2011, take a look at 2011, 2010 Form A, Form B, 2009, etc., and just get yourself acquainted with those questions. And see and answer the following from the QR code. All right, so with that said, I'm going to go over question number 3 with you guys because I think it looks a little bit different. And we actually haven't gone over anything that's similar or, similar, but not exactly the same as this one. So let's go ahead and take a look. So go ahead and read the question, get yourself acquainted with it. Okay, so it has 3 parts. It says a company designs spinning toys using that function where C is a positive and the figure shown above is a region of the first quadrant. Each spinning toy is in the shape of a solid, generally when the region is above about the x-axis. So the x-axis is going to be right there. And so naturally I'm thinking this is going to be my revolution or the evolving around the axis of revolution. So I'm going to have my axis of revolution as horizontal, my radius is going to be vertical. And so obviously that right there tells me that it is going to be in terms of dx. So everything has been solved for y, which it already is, which is good. So part A asks you to find the area of the region in the first quadrant, bounded by the x-axis with that graph, and C is equal to 6. All right, so looking at this here, you know that C, x, square root of 4 minus x squared. And as I'm looking at this right here, I'm going to set it equal to 0. And with that, let's go ahead and take a look at the intersection for this, because I need to know that if I were to find the area, I would need to have the lower and upper bound. And so in this situation, I don't know what this intersection is going to be. and I need to have the upper and lower bounds so I can find the integral of this. So this constant doesn't really matter because I'm setting equal to 0, and as I'm looking for the intersection of this graph right here is represented by the equation itself. So I'm going to set it equal to 0, which is these x-axis right here, which is y equals 0, so I can find the intersection of this. So looking at this part right here, I have c of x equal to 0, square root of 4 minus x squared equal to 0. Well, if I divide it by the c, x is equal to 0, so that's going to be my lower bound. And then here, if I square both sides, 4 minus x squared equals 0. So 4 equals move the x squared over to the right, which makes it a positive x squared. And then x equals plus or minus 2. Well, given the fact that this is in the first quadrant, you cannot use a negative 2. So x cannot equal negative 2. So it has to be positive 2. So from that information there, I know my upper and lower bound is going to be from 0 to 2. And I know that my c is equal to 6, so I'm going to have 6x square root of 4 minus x squared dx. Looking at this here, I know I'm going to use a u substitution, and so naturally I'm going to say let u be inside the square root, which is 4 minus x squared. So then if I go ahead and find the derivative of this is going to give me a negative 2x dx. If I solve for dx, I'm going to have a du over negative 2x. So then let's go ahead and replace this. So area equals integral 0 to 2, 6x u to the 1/2, changing your dx to du over negative 2x. So lucky for me, I can go ahead and cancel out the x. That cancels, and the 6 and the negative 2 cancels, and I'm left with a negative 3. All right, so then looking at this, area equals, that negative 3 is just constant, so I'm going to move it over. So then have u to the 1/2 du. So let's go ahead and proceed forward with integrating this then, because everything is in terms of u, and so far I am good. All right, so then looking at this, from the derivative, you have to add a 1, which is a 3 over 2, divided by a 3 over 2. So then my area is equal to negative 3. I'm going to flip that over, so 2/3 u to the 3 over 2 plus c, and we evaluate this from 0 to 2. Now, before I go ahead and plug in the upper and lower bounds, keep in mind that your upper and lower bounds here are in terms of x's, x equals. So here I need to go ahead and change it with u's. So if I were to change these upper bounds, remember that u equals 4 minus x squared. So for my lower bound, if x equals 0, then u is going to be 4 minus 0, which is just 4. So I'm going to change that to a 4. Similarly, I have to do with my upper bounds. If x equals 2, u is equal to 4 minus 2 squared, which is 0. So that becomes a 0. So then I have a negative 3 times 2. This part cancels. I have a negative 2. U to the 3 over 2. Evaluate it from 0 or 4 to 0. So then let's plug in the upper bound. Okay, if I plug in the upper bound right here, it is going to result in just a simple 0 minus my lower bound. So I have a negative 2 times 4 to the 3 over 2 power. So then with your calculators, 4 to the 3 over 2 power is going to give you an 8. 2 times that is going to give you a 16. And that is going to be your answer, unit squared. Now, if you decided not to go ahead and use u, you could have technically replaced the u back to, in terms of x, which is 4 minus x squared, and then just keep the 0 to 2. That's fine as well, but I figured, like, I don't know, u just seems a lot easier to integrate or not integrate, but to find the answers rather than doing it this way. So it's entirely up to you, but either way, you'll get the same answer. All right, so now let's go ahead and go to the next part, part B. So it is known that this equation here has the rate of change at that. For a particular spinning toy, the radius of the largest cross-section slice is 1.2 inches. What is the value of C for this spinning toy? All right, so you know that the maximum radius occurs when the y is maximum. So then naturally what I think about this is I would need to go ahead and find the critical point, and in order to figure out what the maximum is for this. So then I have 1.2, which is the y value, is equal to c of x square root of 4 minus x squared. Now, it is also given to you that this part right here is your rate of change. So c of 4 minus 2x squared over square root of 4 minus x squared. I'm going to set that equal to 0. If I go ahead and cross multiply this, I will have c 4 minus 2x squared equals 0. So then naturally c equals 0, and then 4 minus 2x squared equals 0. So 4 equals 2x squared, and then x squared equals square root of 2, where your c can't equal to 0. So then looking at this, the only option that I have here is x is equal to square root of 2. So then I'm going to go back over here and replace the square, or the x's, with the square root of 2. So 1.2 is equal to c. And I'm going to replace that x with the square root of 2, square root of 2. So let's go ahead and evaluate this. Square root of 2. Square root of 2 is just going to give me a 2. So 4 minus 2 is just a square root of 2. Square root of 2 times square root of 2 is just 2c. So c equals 1.2 divided by 2. And then c is equal to 0.6 in this situation. All right, so let's go ahead and take a look at part C. For another spinning toy, the volume is 12 pi cubic inches. So what is the value of C for the spinning toy? So if the volume is that, then just remember we're looking at pi with the volume formula from 0 to 2. C of x square root of 4 minus x squared. And remember, it's going to be the radius. You have to do that squared, okay? So it's going to be that radius squared dx. Which is then equal to 2 pi, because that's the volume. Okay, so then looking at this here, I am going to distribute the square because I don't like the fact that it's there. So I'm going to have c squared, x squared, the square and that square root cancels. So you have 4 minus x squared dx equals 2 pi. Well, I have a pi on both sides, so let's just get rid of that altogether. Here I go, just get rid of that. And then c squared is a constant, so let's go ahead and move that c squared on the outside. X squared, I'm going to go ahead and take that x squared and distribute it inside here, because ultimately I'm going to have to integrate this. So let's go ahead and have 4x squared minus x to the 4 dx equals 2. Well, let's go ahead and integrate this thing, guys. So then looking at this, plus 1 equals 3 divided by 3. So I'm going to have c, oh, I forgot my square right here, c squared. I'm going to have 4 over 3x cubed minus 1 over 5x the fifth, evaluated from 0 to 2, equal to 2. Well, if I plug in the upper bounds, I'm going to have c squared, and on top here, it's going to be 2 to the third, which is 8. 8 times 4 is 32 over 3, minus 2 to the fifth power is going to give me 32. So then 32 over 5 equals 2. Well, you're going to have to go ahead and find the common denominator in this situation. And so multiply by 5, multiply that by 3, combine your like terms, and you're going to have 32c squared. Inside, you are going to have 5 times 3 over 15 equals 2. 5 minus 3, sorry. And the 32 here, they're the constant, so you can actually factor that out. So you're just left with a 5 and a 3, so 32 is out. And then if you go ahead and subtract it, 2 times 64, or 32 is going to give me a 64. C squared over 15 equals 2. Well, let's try to get rid of the fraction here with the 64 and 15. So I'm going to do 2 times, my pen is not working. Come on. About that, my pen's battery either died or stopped working for some reason. Okay, so then 15 times 2 over 64, which can be reduced to 15 over 32. Square both sides, c equals the square root of 15 over 32. And that is your answer, you guys. All right, I hope you have a wonderful week. As always, stay safe and healthy. I'll see you guys next time. Take care.